Hey, Plumber Tom here. If you're studying from the Mathematics for Plumbers and Pipefitters book, you've come to the right place. I'm glad to help you with your understanding. Don't forget to check in the description below this video for access to books and resources that will help you with your understanding. There are online courses and other things that you can take that will help you prepare for a state test. When you purchase from those links, you're helping me to be able to create more great content. Thanks for watching. Hello, welcome to this presentation of Mathematics for Plumbers and Pipefitters. My name is Thomas, and in this presentation we are looking at Unit 15, which is equal spacing. Do you know what equal spacing means? This is what sets us apart, the amateurs from the professionals. If you want to look really good as a plumber, then you are capable of equal spacing. Check these pictures out. Check out this guy. His name is Fernando Lobo. He is an absolute pipe wizard. He does hydronic heat, but he does it in threaded steel, and he treats the water so that the steel will last. But the most amazing thing is his organization, his eye for detail, and the way that he sets up these pipes. Fernando was recently showcased in the Plumbing and Mechanical magazine because of his ability to do this. To take pipes, create equal spacing and order that just looks fantastic. I mean, this is like art. Let me show you the opposite. See, there's a lot of pipe in here and they're different systems all run over each other, but it's disgusting. Look at this. Like, there's no equal spacing. This isn't professional. This is just a bunch of hacks throwing stuff together. A lot of this isn't even up to code. Who do you want to be? Look, it really doesn't take that much time to cut your pipes and line them up so that they look nice and you have equal spacing. And that's a mark of a professional. That's how you need to be. You can see that equal spacing makes all the difference. It makes it look awesome. You can have an incredible piping presentation as you're installing these systems. And let's look in Unit 15 at how we can set that up so that as we're installing pipes, we can have these nice, even, equal spaces, make it look awesome. Let's start off with this diagram from Unit 15. It shows us a 90, a T, and a 45. Now we want to create equal spacing, so they're saying here we have 22 inches between the center of the 90 and the center of the T, and 22 inches between the center of the T and the center of the 45. But they point out that even though your center to center measurements are the same, and that's what you want to make it look awesome, your cut, your end-to-end measurement is going to be different, because between the 90 and the T, you're going to need to do some fitting allowance, some takeoff, right? So you subtract for the 90 and you subtract for the T, and you get a pipe length. But then you go to the other side and you're going to subtract for the T, and you're going to subtract for the 45 fitting allowance, and you're going to have a different length. So when we talk about equal spacing, we're not just talking about cutting the same piece of pipe and sticking it in between fittings. That's not going to give you the evenly spaced perfection that we want, center to center. You've got to be able to say, okay, this is what I want, center to center. Now what do I need to subtract so that all of these are the same, even if the fittings are different? Hey, not a lot of explanation in this unit. We're jumping right into the sample problem. Here we have it. The sample problem has a total distance of 20 and 5/16 inches from the 90 on the left to the 90 on the right, and in between there we have two T's that are branching off, and we'd like to make it look awesome. So we're going to try and space those equally, get those T's set. How do we go about this? How do we figure this out? Let's check out the step-by-step. Here we go, the solution for our sample problem. Step 1, first we really ought to convert that 20 and 5/16 of an inch into a decimal, because we're going to be chopping this thing up, and it's no fun chopping up fractions. It's so much easier on a calculator. Just turn it into a decimal. So here we go. Plug that into a calculator and we get 20.312. Now they have the data table 1. You can go look it up in the back if you want a quick conversion of a fraction to a decimal. The other way to do that is just to divide 5 divided by 16. You're going to get 0.312. That's how you turn a fraction into a decimal. Divide. Okay. Moving on to step 2, you're going to divide that number, 20.312, by 3 because we want 3 equal spaces. If you remember from the diagram, we have the 90 to the T to the T, and the T to the 90. That's 3 spaces. We divide it by 3 and we end up with 6.770. That's our center to center measurement for each of those sections. Then step 3, they say let's convert 0.77 back to the nearest 16th of an inch. We're going to go back to fractions so we can measure it on our measuring tape. If you times 0.77 by 16 over 16, you're going to get 12.32 over 16. Now we've created this fraction, but we need to reduce or just round that thing. Let's just call it 12 over 16. 12/16 can be reduced to 3/4. So back to the sample problem solution, 6.77, pretty close to 6 3/4 of an inch. That's what we're looking for center to center as we're doing equal spacing for this sample problem. In Unit 15, there are 4 exercise problems, and each of these is a little bit involved. You're going to find out the center to center for the different sections, and then you're going to figure out the threaded end-to-end cuts you're going to have to subtract for fittings. You're going to figure out the copper end-to-end cuts, and you're going to find out the PVC end-to-end cuts. So a little legwork here. But to help you out, I'm going to do exercise number 1 together with you. That way you can follow the pattern on how we go through these, and then you can do the same thing on these others. Then I will turn you loose and you can do number 2, number 3, and number 4. They're going to be different numbers of equal distance sections. And if you look at number 4, don't be too alarmed. Just because it's on an angle, we're still dealing with the same thing. Just figure out your sections, take off your fittings, get your end-to-end measurements. So let's do this one, number 1. Have a close look here at the sample problem, and then I'm going to grind through it with you. First of all, we see the diagram on the top. The overall is 17.5. We have a 90, a T, and a 90. And we want to put that T right in the center because it looks awesome. So what I see here are 2 sections. First thing we should do here is we follow the steps to get to our solution. Let's take the 17.5 and convert that over into a decimal. So 17.5 is what we would get. Then the second step, we're going to divide that 17.5 by 2 because we have 2 equal spaces we're trying to create. And that would give us 8.75 inches is what we're dealing with. And we can convert that back over into fractions pretty easy because 0.75 is 3/4. So really what you're getting here is, for J, our center to center measurement is 8 3/4, and for K, our center to center measurement is also 8 3/4. That's our starting point. We have our center to center. Now we need to go back through each of these types of pipe and subtract for the fittings. Note at the bottom of the diagram here that we have 1/2 inch pipe. We're going to go back to our data tables as we've done in the past. We'll figure out what we need to subtract off, and then we can get our end to end. So let's go to the data table, remembering that we're dealing with a 1/2 inch threaded pipe first off. We have a look here, data table 5. We're going to start out with threaded. First, let's go to the far left column. We're looking for nominal pipe size 1/2 inch. So we're going to follow it down. We find 1/2 inch. Follow that row across. For a 90, remember on threaded, we have to take from the face to the center and then subtract how far the pipe goes in. So these ones are a little more involved, but here we go. 1 1/8 from the face to the center on this threaded 1/2 inch fitting. And then we look over on B. B is how far the pipe goes into the threaded fitting, and we have 1/2 of an inch. So in order to get our fitting takeoff for these 90s, we're going to say 1/8 of an inch minus 1/2 of an inch, and that's going to leave us with 5/8 of an inch. That's the takeoff for the 90. Have a look here on data table 7. Data table 7 gives us the fitting allowances for T's. The table is going to work very much like the elbows we were just looking at, but this time we're dealing with just straight up T's. Now, please recognize that there are T's And then there are sanitary tees and there are Ys, or in the book they call them TYs. These tees are just low profile, tight, 90-degree angle output. These are just basic tees that we're dealing with, okay? And that's what we'll be doing on all of the assignments. So come to this data table 7. Once again, we're dealing with 1/2-inch pipe, so let's look for 1/2-inch threaded. We follow this down, 1/2-inch threaded. Oh, look at this. We have the same face to center measurement as the 90. It's 1 1/8 of an inch. Then how far does the pipe thread in? We have B. It's the same, it's 1/2 of an inch. So the takeoff for the threaded on the T is going to be the same, which is 5/8 of an inch. I've pulled up my notebook here. Let's crank through some of these calculations together. It's a good idea for you to have a notebook, scratch paper, something you can just lay these numbers out, right? So let's start out with what we know. Center to center measurement, as we took that 17.5 and we divided that by 2 to get our equal spacing. If you remember, we got 8.75, which is equal to 8 3/4 of an inch. That's our center to center for both J and K. Now for our threaded, let's have a look at that. Threaded pipe, if you remember the takeoff, we would take for J, for example, J would equal 8 3/4 of an inch minus 5/8 of an inch plus 5/8 of an inch. We have 2 of those, right? It was 5/8 for the 90, 5/8 for the T. If we combine those, I'm going to have 8 3/4 of an inch minus 5/8 plus 5/8 is going to give me 10/8. And that can be simplified, right? That's the same as 8 3/4 minus 1 2/8, which is the same as 1 1/4. We just reduced that, right? So 8 3/4 minus 1 1/4. This one works out pretty well because we have common denominator now. And we're going to end up with 7.5. Now that is our end to end for threaded pipe, right? Noted. Now if I've got 7.5 for J and I look at K, and K has a T and a 90, we're dealing with the same fittings, so I know that for my threaded, the end to end for J is 7.5 and the end to end for K is also 7.5. Let's have a look here at data table 5 as we are examining for the copper fittings. Follow again the line down to 1/2 inch. As we come across, this time we're given just straight up. G is what we subtract. We don't have to do the face to the center minus how far the pipe goes in as with the threaded fittings. We're just going to take G where it's at. So for a 1/2 inch copper 90, we have 3/8 of an inch is our takeoff for the 90. Here we are, data table 7 again. This time we're looking for a copper T. We need the takeoff. Let's follow the column on the left down to 1/2 inch, come across to copper. A copper T is going to have a takeoff of 3/8 of an inch. All right, let's figure out our copper end-to-end measurements. We're going to start with our 8 3/4 of an inch for J, for example. And if you remember, each of the fittings, the 90 and the T, had a fitting allowance of 3/8 of an inch. So we'll have 3/8 and 3/8. If we add those together, we're going to get 3/4 of an inch. This one looks pretty simple, doesn't it? Because we have 8 3/4. Did you see how I wrote backwards? That was kind of interesting, huh? 8 3/4 minus 3/4, what do you get? It equals 8. So that would be J equals 8. But again, K is also the same, so K equals 8 inches. Let's have another look here. Data table 5, we've got the PVC that we're looking for this time. We're going to find our pipe size on the left column, come down to the row that has 1/2 inch, follow it all the way across, and we're looking at the PVC 90 as we come down in that column. For a 1/2 inch 90, we have 1/2 of an inch is our takeoff. Again, we're looking at G. That's just what we need to subtract, so let's use that, 1/2 inch. Once again, data table 7. This time we're looking for PVC takeoff. We come down to the 1/2 inch line, come all the way across to our PVC, and no, we are not surprised to find out that it is the same again as the 90. We have a 1/2 inch. We have 1/2 inch is our fitting allowance that we will subtract. Now please note that just because these ones are all the same as the 90s does not mean that they will always be the same when you look them up in the back of the book here, or when you're dealing with them in the field. So sometimes they are, sometimes they're not. Let's take it and do our PVC. PVC end-to-end measurement is going to equal 8 3/4 minus the fittings, which each one was a 1/2 inch. So that's 1/2 inch plus 1/2 inch. So we get 8 3/4 minus 1 inch, and that would give us 7 3/4 inch for our PVC. Now that's for J and for K. So as we finish this off, let's just fill in our exercise 1. If you remember, we have center to center for J and K are both 8 3/4. Then we go to the threaded end to end. Our threaded end to end measurements were 7.5 for J and 7.5 for K. Our end to end measurements for copper, J was 8 inches and K was 8 inches. And our end to end measurements for PVC, J was 7 3/4 and K was 7 3/4. Now I know what you're thinking. Hey Tom, why don't you do number 2 and number 3 and number 4? But I'm not going to. What I'm going to do is I'm going to let you do number 2, 3, and 4. Please figure out the center to centers and then your end to end for each of the types of pipe. Good luck with your assignment, and I'll see you in the next one.